for automated driving applications. So I'll be presenting our capabilities for developing and verifying the autonomous driving systems, with MATLAB, Simulink, and RoadRunner. My name is Martin, and I'm application engineer at Matrix, located in Sweden. So today's agenda, there are four topics today. So first one, I am going to spend a few minutes on giving you an overview of what Matrix offer for, in general for ADAS and AD. And then I'm going to also talk about how to design, simulate, and build scenarios with RoadRunner. And and the scenarios, it's mainly driven by this safety standard, which is called SORTIF. And third topic is about a general overview of our reference workflow of ISO 26262, which is a functional safety standard in automotive. And the final topic is regarding AI. So this section will be an inspirational topic today. So we will spend a few minutes on talking about how AI can fit into our ADAS and AD project. So I hope you can at the end of this section, you will get some ideas on how to use our products for developing and verifying the ADAS and AD. Okay, and also feel free to type questions in the chat if this is possible, or I don't know how well, maybe raise up your hand. So I will be happy to try to answer your question during the presentation. Okay, so let's get started on the first topic, the overview of ADAS and AD. So since I'm going to talk about the scenarios and the functional safety reference workflow of developing the autonomous systems, so this is mainly driven by two standards. One is the SORTIF, and the other is the ISO 26262. And all if we see this as from a top-down view, right? These are all driven by analyzing or ensuring the vehicle safety. And it all start from this vehicle level, this hazard, there are, let's say, which can result in let's say accidents or a life-threatening this hazard. Okay, so as maybe we are familiar with this ISO 26262, so it's a functional safety standard for electrical and electronic systems in the vehicles, right? So it kind of handles failures from a system level, the hardware level, and the software level. There are so it's kind of a sort of workflow or kind of the standard, which allows you to systematically analyze the hazard of the system, and as well as to to isolate the failures and to handle the failures. But specifically to ADAS and AD, right? This ISO 26262 standard might not be capable of handling all these hazards because of the limitation of the perhaps the sensors or perhaps the algorithms. Okay, so that's why we have this SORTIF standard as a kind of a compensation in terms of functional safety. Because let's imagine if the algorithm or the sensor has limitations and it can't detect, let's say, an obstacle in front of the ego vehicle, right? And this is not a failure of the system, or this is even not a malfunction of the electrical or the electronic system, right? It's the limitation of the ADAS and AD system. It's the limitations of the sensors. There's nothing to do with malfunctions or failures, or errors, right? So that's why, beyond the ISO 26262, we have the SORTIF, right? So the SORTIF is for handling all kinds of, these algorithm sensors and all these foreseeable algorithms misuse, and etc., right? So this is how this functional safety standard comes from, right? And today we are going to spend more time on talking about sortive, meaning to design, to simulate, and to build the scenarios. And we will spend a little bit, maybe less time on talking about the ISO 26262. Okay. So maybe a little bit more details about the sortive. It's according to this SAE J3016 standard. In order to kind of follow this sortive standard, we should have the structure. We should structure the environment, so which is called the ODD, which is short for Operational Design Domain, right? So in this standard, it refer us to different categories to structure the ODD. The scene, which include road networks, the structures of the roadside, or any like let's say buildings or trees or any temporal structures, or the road, let's say the roadblocks, traffic signs, and etc. It also includes any dynamic objects such as the traffics, the vehicles, the pedestrians. It also includes any environment conditions such as the weather, right? So this is coming from the sortive, the standard, okay? And so beyond the standard, in order to kind of verify the ADAS and AD system under the ODD, right? So this is a very high level diagram of the ADAS and AD system, right? So this is framework for verification and validation. So first of all, we should have a proper external environment, either in like physics, let's say if you drive the vehicle on the public road, and then to kind of test the ADAS and AD, or it is a simulation environment, which is the simulator, right? And secondly, we have the sensors for the ADAS and AD, and the actuators and the vehicle dynamics, right? Of course, and as well as the algorithms. The algorithms include perception, planning, and control, and any other like these algorithms, let's say for predicting the object and etc. Right? Anyway, so this algorithm is a system that under test, right? So the virtual sensors, virtual simulation environment, the actuator models, as well as the vehicle dynamics, these blocks are all reserved for verifying and validating the ADAS and AD system that is under test, right? So this is the kind of the high-level picture of the framework, right? And even more is, since the ADAS accept the fully automated system, which is level 5, the system usually includes the driver in the loop, right? And the HMI, the human machine interfaces. So this, if we also include this part, we should also consider, let's say, how to kind of verify and validate the driver behaviors, the effect of the human machine interfaces in the loop. So this is a closed loop system. And this system, all this framework is for us to verify the whole ADAS and AD system. So how could we measure the maturity of the ADAS and AD development and simulation under this framework, right? So as you might know, model-based design, right? So we are a company, so we offer, let's say, Simulink products, which is for mainly for model-based design methodology, right? So there are different levels for performing the simulations. We usually start from model in the loop testing, which the models, let's say the models for the algorithms, or for sensors, driver models, vehicle dynamics, all the scenarios and scenes. So these are regarded as models, right? So model in the loop, meaning that we kind of close the loop, and perform simulations in our desktop simulation environment, right? And followed by software in the loop testing. So in the software in the loop testing, so we will generate the code and we will test the code with the models, right? And followed by PIL, processor in the loop, HIL, hardware in the loop, and DIL, meaning the driver in the loop, right? So as we perform, this MIL, SIL, PIL, HIL, and DIL, so we will gain more confidence of the ADAS and AD system. Sorry. So and this is one of the example that how shows how how Simulink can kind of help you to perform this MIL, SIL, PIL, HIL, and DIL, right? So as you can see in these recordings, we have tools for this the Simulink for developing the algorithms or integrating the vehicle dynamics. We also have the tool for providing these scenes and scenarios, and which also allows you to co-simulate with the the system under test. And we also have the tool that allows you to perform post-processing of the data from the simulation. And you can also replay the scenarios and perform aggregate analysis.